For Chapter 7 summative, we're going to go over the review today. Notice you have two learning targets. The first one, AO7P, is I can solve inequalities. So that's the actual solving of the compound inequalities and multi-step inequalities as well as absolute value. AO7A is your application part, so I can model and apply inequality story problems. So those are the last three problems on here. To begin today, number one, remember when solving, draw the line down the center. Inverse operations, just like if it was an equation. Minus 20 on both sides. Negative 6 is greater than 2/3 x. To get rid of our fraction here, we are able to multiply by the reciprocal so that it cancels. Then I'm going to multiply the other side by that reciprocal as well. So I have negative 18 over 2 is greater than x. Negative 18 over 2 is really just negative 9 is greater than x. So here is my answer. Then I need to graph. When I graph, I like to look at it the other way, so I like to think of it as x is less than negative 9. So on my number line, we have negative 10, negative 9, negative 8. Open circle at negative 9, and x is less, so we're going to go down the number line with that arrow. Number 2, this time I have parentheses, so I see I'm going to distribute that negative 2 in, so I have a negative 8x minus 6 is less than or equal to 9. Add 6 to both sides. Negative 8x is less than or equal to 15. Divide by negative 8x. And because I divided by my negative here, we have to remember that with inequalities, we reverse our sign. So it's greater than or equal to negative 15/8. If you change it to a decimal, that's completely fine. But here is my answer. And when I graph negative 15/8, negative 16/8, which is negative 2, negative 14/8, we have a closed circle. X is greater, so we're going to go up that number line. Last but not least, number 3, draw your line on the center, and I'm going to distribute right away on both sides. Negative 3 times 4 is negative 12. Negative 3 times negative 1x is positive 3x. It's greater than or equal to 6x minus 20. Just as if this was an equation, you're going to bring all the x's to one side and all the numbers to the other. Doesn't matter which way you do it, we should end up with the same answer. I personally like to move my x's to the left, so I'm going to subtract 6x on both sides to start. So I have negative 12 minus 3x greater than or equal to negative 20. Add 12 on both sides. Negative 3x greater than or equal to negative 8. Divide by negative 3. Because I am dividing by that negative, right here, I need to remember to flip my sign. X is greater than or equal to a positive 8/3. If you change it to a decimal, that's completely fine, but we still have to graph regardless. So I have 7/3, 8/3, and 9/3, which is really 3. We have a closed circle at 8/3. X is less, so I'm going to go down the number line with that arrow. Those are numbers 1, 2, and 3. Number 4 is a compound inequality. Because it only has one variable, okay, because it only has one variable, I can go ahead and solve this all at once, just like we've done in the past. I'm going to start by, remember, we have to isolate my c. Right now, I have to get rid of that 2 first. I'm going to subtract 2 in all sections. So I have negative 10 is less than or equal to 4/5 c, which is less than 20. To get rid of that fraction, if I want to do it all in one step, I'm going to multiply by the reciprocal. Multiply by 5/4 to cancel. Multiply by 5/4 on every section. When I do so, I get negative 50 over 4 is less than or equal to C, which is less than 100 over 4. Now, I don't mind fractions, but they still have to be reduced, and you can use a calculator. So if I put this in my calculator, I end up getting negative 12.5. So less than or equal to C, which is less than 25. So when I graph this, if this is 0, here is 25. Here is negative 12.5. I would expect you to be a little more accurate than me, but that's okay. And at negative 12.5, I have a closed circle. At 25, I have an open circle. And because this is an and compound inequality, I'm going to go ahead and connect my dots. Anything between those two values is a solution that works for this problem. Number 5 is another compound inequality, but this time is an OR statement. So I have to just solve these as two individual problems. I will multiply by a negative 4 to cancel, so I have B alone, and multiply by a negative 4. Because I am multiplying by that negative, I have to remember to flip my sign, and I get negative 56. On my other side, I divide by 6, and I have B is greater than negative 2. So I have for my answer, B is less than negative 56, or B is greater than negative 2. Now when I graph this, because my numbers are so far apart, here on the bottom of my number line, I'm going to have 57, negative 56, and negative 55. And then by putting in this zigzag, that means there's going to be a break in my number line. Then I have negative 3, negative 2, negative 1, and 0. At negative 56, I am going to have an open circle, and B is less, so it's going to go down. At negative 2, I will also have an open circle, but B is greater, so it's going to go up. Notice because it's an OR statement, my arrows go apart from each other. Next, we have absolute value problems. Here's where you need to be really careful. Number 6, you can look back at the number 6 notes if you forgot how to do this. But anytime we're solving an inequality problem, or an absolute value problem, we have to isolate the absolute value. So first I need to get this absolute value all by itself. To do so, I have to minus 10 on both sides. So I have the absolute value of 1/2 x plus 9 equals negative 3. Right here, I can stop. An absolute value cannot equal any kind of negative number. Because it's a negative number over here, I can automatically say no solution. I don't need to continue solving. Don't let that trick you. Number 7 is an absolute value inequality. This is out of your number 7 notes if you forgot how to do this. They're very similar processes for equations and inequalities, but they are different, so please make sure you have that straight in your head. But just like an equation, I'm going to have to isolate that absolute value. The first thing I need to get rid of is the standalone 4, so I have to minus 4 from both sides. So I have 3 absolute value of x plus 2 is less than 9. I still have not yet isolated this absolute value, so I have to get rid of the 3. The 3 is being multiplied with the absolute value, so I would divide by 3 on both sides to get rid of it. Absolute value of x plus 2 is less than 3. And that's step 1. Step 2, once you have it isolated, you need to rewrite. Because it is less than, I'm going to make an AND statement. So I take what's inside my absolute value, and I'm going to sandwich it between the positive 3 and a negative 3. Once I have it rewritten, all I need to do is solve. So draw my lines, subtract 2 in all sections. Negative 5 is less than x, which is less than 1. Here is my solution. Make sure you have all of those steps to get to your final answer.